Hi, welcome to the video solution for past paper. This is Cambridge International A-Level Mathematics paper P1 October-November 2019 paper 1-2. So let's start. Question number 1, the coefficient of x square in the expression of 4 plus ax times 1 plus x by 2 whole power 6 is 3. Find the value of the constant a. So we need to find value of a such that if we find the coefficient of x square in this whole expression, which should be 3, so using this given information we can figure out value of a. We will have to find first the terms involving x square in these expression. So we know that we have this factor with the linear power of 1, so we don't need to do anything with this factor, but this is binomial expansion. So we will have to first expand this binomial expansion till the term that we can think that involve x square term. So how do we expand this 1 plus x by 2 whole power 6? So remember, this is just for your reference. If you have any form of binomial expansion, 1 plus x whole power n. So we can expand this binomial expansion using approach or using a formula. 1 plus nx plus n minus 1 divided by 2 factorial into x square plus n minus 1 n minus 2 divided by 3 factorial into x cube, and we can keep going on and on and on until we reach the term n at the end. So the idea, if you you see that you the first choice is you will have to memorize this formula, or it is given in your formula sheet, or you can find some trend to memorize this, so it will be a good idea. So we will use this expansion to find the number of terms that involve x squared. That means if you see this is the fourth term that involve x cube, so we don't need x cube because we need only coefficient of x squared. So we will have to open this 1 plus x by 2 whole power 6 till 3 terms. So if you apply the same expansion on 1 plus x by 2, so you can write 1 plus x by 2 whole power 6 is equal to 1 plus 6 into x by 2, because this is nx, plus n into n minus 1, and n is 6, so you say that 6 into 5 divided by 2 factorial into x square, and x square means the square of the second term, which is x square by 4, plus you don't need to write next terms, and you simplify this, so you have a 1 plus 2 times 6 is 3, so 1 plus 3x plus 2 factorial is 2, 2 4s are 8, 6 5s are 30. So if you simplify this, you can say that you can have a 2 3, so 15 upon 4 x square. So these are the three terms of the expansion 1 plus x by 2 whole power 6. And now this is another confusing step for students. Generally students think that 15 by 4 is the coefficient of x square. This is not the case, because you need to find the coefficient of x square after multiplying this expansion with 4 plus ax. So you will have to multiply this expansion with 4 plus ax. So this implies that 4 plus ax times 1 plus 3x plus 15 by 4 x square. And now you don't need to multiply each and every term in these two factors, because we need to know only coefficient of x squared terms. So you can see that if you multiply 4 with 1, it's just waste of time because you don't have a square term. Similarly, if you multiply 4 with 3x, so it will be 12x. So it, again, waste of time writing of this term. But if you multiply 4 with 15 by 4x square, so you have, this is the term involving x square. Similarly, multiplying ax and writing ax into 1 will be waste of time. But if you multiply ax with 3x, it will give you another square term, x square term. And if you multiply ax with the last term, so it will give you the term involving x cube. So again, waste of time. So you will have to multiply only this 4 with the last term, so you can have a term involving x square, and then ax with the 3x, so you have only two terms involving x square. So finally you have 15 by 4 x square multiplied by 4, so 4 gets cancelled. That means 15 x square plus ax multiplied by 3x, so 3ax squared. So finally you can make a coefficient of x square by taking x square common, so 15 plus 3a into x square. So this is the term involving x square, and this is the coefficient, and question says the coefficient of this x square term is 3. So now you can say, according to condition, 15 plus 3a should be equal to 3. And then you can simplify this for a. If you simplify this, so send 15 to the other side, so 3a is equal to minus 12, 3 minus 15, and then clearly a is equal to minus 4. So this is the value of a that we need to find. Question number 2. The point M is the midpoint of the line joining the points 3, 7 and minus 1, 1. Find the equation of the line through M, which is parallel to the line x by 3 plus y by 2 is equal to 1. Okay, so we can solve this question without visualizing the situation, just knowing the condition. But in my opinion, this is a question from coordinate geometry, so it is a good idea if we can sketch the condition, so we can visualize more better, and we can have a more idea about what to do with this. So first they are saying that the point M is the midpoint of the line joining these two. So we sketch these 2 points on a rough axis. So this is my, suppose x-axis and y-axis. And you say 3, 7. So 3, 7 is somewhere 3. And let's just talk about, let's suppose this is 3, 7. This is the point 3, 7. Let's call this point A. And another point is minus 1 and 1. So minus 1 is minus 1 and 1. So clearly you can see that minus 1 and 1. Another point, let's call it B. And we have a line passing through these 2 points. So we can say that a line, let's suppose a line passing through from these 2 points. And then M is the midpoint of the line joining the point D. So we have a midpoint of these two. So midpoint of these two points M will be somewhere here. Let's suppose this is the point M. It should be a midpoint, so slightly lower here somewhere. This is M here. Okay, and now find the equation of the line, another line passing through M, which is parallel to x by 3 and y by 2. If you see this equation, this is the another standard equation, in which if you are given equation in this form, like x by some number plus y by another number is equal to 1. So these two, a and b, these two are intercepts. So this is x-intercept, x-intercept, and this one is y-intercept. So we can sketch this line as well. That means x-intercept is 3 and y-intercept is 2. So you can think that you have an intercept, x-intercept is 3. So this is 3, and then another intercept is 2. So this is 2, like somewhere here, maybe. Yeah, let's say here. This is 2. And now we can sketch the line passing through these two intercepts. I guess we should be, maybe something like this. Let's imagine this is the x-intercept 3. And then they are saying that a line passing through M parallel to this line. So we have unknown line passing through M parallel to this. So you can sketch another line like this. This is our required line. That's what we need to, find the equation of that line. So the idea is, if you find the midpoint of AB, then we have coordinate of M. So we have a point. And then from this line, we can figure out a gradient of the given line, which will be same for our required line. So we can find the equation of the yellow line, because you need a gradient and the point of a line in order to find the equation. So point is already given in terms of a midpoint. So let's just talk about for M, which is midpoint. So M will be equal to, the coordinate of M will be equal to x1 plus x2 divided by 2. So that means 3 minus 1, x1 plus x2, 3 minus 1 divided by 2, comma, y1 plus y2, so 7 plus 1 divided by 2. This is the midpoint. And then M will be equal to 3 minus 1 is 2, 2 by 2 is 1, comma, 7 plus 8, 4, 1, comma, 4. This is the midpoint coordinate of the point M. And then you can rearrange this given equation in the form of y equal to mx plus c. So you can have gradient of this given line. So rearrange this equation in the form of this. So you know that you can rearrange and you can write as y is equal to y. Okay. So you can send x by 3 on the other side. So y by 2 is equal to 1 minus x by 3. Or you can say minus x by 3 plus 1, because we have x term first and then constant. And then send this 2 to the other side. So you have a y is equal to minus 2 by 3x plus 2. So now clearly we have m1, which is minus 2 by 3. This is gradient of the given line. Now our required line is parallel to the given one, so m2 is also minus 2 by 3. I'm writing these steps just for your understanding. You don't need to write this step. You can ignore this just to save the time. So now you have a gradient of your required line, the yellow one. That's what we need to find. So now the idea of finding equation is we use a slope point or gradient point form, which is y minus y1 is equal to m times of x minus x1. So this is the general form of any equation that says that if you have a point x1 y1 and you have a gradient of that particular line, so you can find the equation. We have a gradient which is minus 2 by 3. We have a point y1 and x1, which is point m. We can substitute these values to find the equation. So y minus y1, which is y coordinate of the point, which is 4, is equal to m is gradient of the line, which is minus 2 by 3, x minus x1, x minus x1, which is 4, so x minus 1. Just simplify this equation, so you can have a 3y minus 12 is equal to minus 2x and then plus 2, and then rearrange for a standard form. If you wish, you can send minus 2x and 2 to the other side, so finally you have a 2x plus 3y and minus 12 and minus 2. So minus 14 equal to 0. This is the equation of your required line passing through the midpoint of the 2 point A and B. Question number 3. A curve is such that dy by dx is equal to k by root x, where k is a constant. The point P1 minus 1 and Q44 lie on the curve. Find the equation of the curve. Okay. So we are given the derivative of some equation, and this derivative is basically gradient of a tangent line to the curve, and we need to find equation. Okay, fine. So if you need to find the equation of the curve and the gradient is given, so that means uh, you just integrate the given derivative. So if you integrate, that means you can have equation of the curve. That's what you need to do. But in this case, when you integrate the derivative, so the integration involves c, that what we call constant of integration. That so we need to find a equation of a particular curve which has this derivative, and then yeah, two unknowns are there, so c and k are also there. So first let's we integrate this derivative. So in order to integrate this, we need to separate the variable, one variable one side of the equation, equal sign, and the other variable to the other side. So you rearrange this equation as dy is equal to k dx by root x. And of course you need to integrate it, so integration sign is just intermediate step for your understanding. K is constant, so you can write outside the integral sign, and then you can write dx, because we cannot integrate at this moment. If something is in a denominator, send this root x up. So yeah, so you will write it as x to the power minus half into dx. So this is intermediate form. If you wish, you can write, otherwise you can directly do that. So integral of dy, which is y, and k is constant, so k remains as it is, and integral of x to the power minus half is x to the power minus half plus 1, which is half, and divided by with the same power minus half plus 1, which is half. We are integrating, so we will have to write constant of integration c. And now, because this is a general equation of a curve, any curve which is has some values k and c, we need to find a particular equation. So we need to find value of c and value of k as well. So two unknowns we need to figure out first, and that's why they gave us 2 points, point P and point Q. And the purpose of these 2 points is because these points lie on the curve, so we You put these points one by one, and we can have two different equations in terms of c and k that can be solved simultaneously to find value of k and c. This is the idea that we are using here. So let's call this equation number 1. Now for point p1 minus 1, I'm using point p1 minus 1, substituting this point in the curve, which is equation number 1. That means if x is 1, then y is minus 1. So you can substitute here minus 1 is equal to k, x is 1, so 1 to the power half divided by half, and this 2 goes up and becomes 2k plus c. So finally you have equation minus 1 or 2k plus c. 2k plus c is equal to minus 1. 2k plus c is equal to minus 1. Minus 1, let's call this equation number 2. And then for q, 4 4, substitute 4 4 in again in equation number 1. So 4 is equal to 2k times 4 to the power half, which is in fact a root, plus c. So 4 is equal to 4k, because 4 root is 2, 2 times 2 is 4, so 4k plus c, and 4k plus c is equal to 4. This is equation number 3. And now we have two unknown k and c, and we have two equation 2 and 3. We can solve these two simultaneously. These are simultaneous equation, so you can use substitution method, or you can use elimination method. Whatever method you choose, you will have to figure out c and k one by one. So let's see if you can, because okay, so let's subtract these two. So that means 4k plus c is equal to 4, and 2k plus c is equal to minus 1. If you subtract these, so you change the sign, so plus, minus, and then minus. So c and c gone, so 4k and minus 2k, so you have 2k is equal to 4 plus 1 5, so k is equal to 5 by 2. Now you have a k 5 by 2. You substitute 5 by 2 in any one of the equation, like equation number 2. So this implies that twice of, or you can say 2 implies that twice of k is 5 by 2, plus c, that's what we need to find from here, and is equal to minus 1. So 2 gone, and 5 plus c is equal to 1. So c is equal to 1 minus 5. Then c is equal to, it was not 1, minus 1. So this should be minus 1. So minus 1 and minus 5. So c is equal to minus 6. Now we have a value of c, we have a value of k. So the equation of the curve is y is equal to, you can substitute here k, which is 5 by 2, and c, it is not k, it is 2k, because this 2 will come here like this. So y is equal to twice of the k, twice of k is 5 by 2, into x to the power half, or you can say root x, plus c, and c is minus 6. So 2 cancel, so y is equal to 5 root x minus c. So that's how you can find the equation of the curve. Question number 4. The diagram shows a circle with center O and radius r centimeter. The point A and B lie on the circle and angle AOB is 2 theta radians. The tangent to the circle at A and B meet at T. Everything is given in the diagram. Express the perimeter of the shaded region in terms of r and theta. Okay, so perimeter of the shaded region in terms of r and theta, that means AT, TB and arc length BA, or arc length AB plus BT and plus TA. So this is the perimeter of the shaded region. So you see that this is just for your reference, I'm writing here, the perimeter is basically AT plus TB plus arc length of AB. So if we're able to find these three lengths, we can find the perimeter. And in this case, because these two are tangents from same point, so length of AT and TB will be same. So you can say that twice of AT plus arc length of AB. So this will be the parameter that we need to figure out in terms of r and theta. And then let's just find out first AB, because this is quite straightforward, a value, because we have arc length and we are given theta. So since the arc length AB will be equal to r theta, because you know the arc length, if you have a circle and this is the r and this is s, arc length, and this angle is theta, so arc length s is equal to r theta. So arc length AB would be equal to angle, and angle is given 2 theta. So 2 theta into the radius, and radius is r. So that means a arc length AB is 2r theta. And also we need to find the length of the tangent AT. And how do you do that? So if you see the whole picture as a triangle like this, draw the line. Clearly the whole angle is 2 theta, so this angle is theta. Now you can see that tangent of theta is equal to opposite over hypotenuse, and in this case opposite is AT, which is AT, divided by adjacent, and adjacent is R. The reason is because this is the normal passing through the center of the circle, and this line is tangent, so this angle must be 90 degree. So this is the right angle triangle. That's what I'm using here. So this is 90 degree, hypotenuse, opposite and adjacent. So adjacent is R, meaning AT is equal to R tangent of theta. So now we can figure out perimeter P is twice of AT, and twice of AT, and AT is R tangent theta. Yeah, 2r tangent theta plus arc length of AB, which is 2r theta. So you can leave your answer here. This is acceptable value, 2r tangent theta plus 2r theta. Clearly you can take 2r if you wish. So perimeter P would be equal to 2r common. Inside the bracket you have tangent theta plus theta. This is the perimeter in terms of r and theta. Okay, part 2, in case where r is equal to 5 and theta is equal to 1.2, find the area of the shaded region. So area of the shaded region is So remember this value. So you can find the 80 because we need these length in the area. So okay, r tangent theta and 2r theta. So part 2, the solution will be r is 5 and theta is 1.2. So first we find the area of this whole triangle. The idea is I'm going to find area of this whole triangle, and after finding area of the one triangle I can double it, so we can have area of this whole rectangle, you know. And then I'm going to find area of this sector, and subtracting this area of the rectangle and this sector, we can have area of the shaded region. So area of so area of right triangle OAT. OAT. So you can say that this is called area A1, I'm calling it. So half of base into height. So base is R and height is 80. You can see that R into R tangent theta. But tangent, theta and R are given. So half of R is 5, which is 5 into 5 tangent of 1.2. You can use your calculator to find the value of tangent 1.2, and then you can 5 times 5 25, so 25 upon 2, which is 12.5, and then tangent 1.2. One of the most important step or mistake the student can have here is, remember your calculator will be in degree before this question, because most of the time we keep our calculator in degree, but here in this particular question the angle is given in radian here. So when you need to find tangent 1.2, make sure that you either convert 1.2 into degree, or change your mode of calculator from degree to radian, and then calculate tangent 1.2. So your tangent 1.2 would be equal to 2.57, and then A1, which is 32.15 centimeter square, because R is given in centimeter here, and this is the area of just triangle above, and the whole the area of whole, the rectangle ATBO A. So the whole area will be twice of A1. So double this area, it will give you 64.15 is 3, yes, centimeter square. So this is the twice of the A1. And now area of the sector, area of the sector, you can figure out. So area of this sector of the circle, and it will be, let's call it A2. So area of the sector is half of, generally area of any sector, the formula for area of the sector, half of r square theta. If you need to find area of the sector, angle theta, radius r, so half of r square theta, but in our sector angle is given 2 theta, so half of r square 2 theta. So 2 and 2 cancel, r is 5, theta is 1.2, so 25 r square, which is r is 5, so 25 times of theta, which is 1.2. If you multiply this, so a would be equal to 30, A2 would be equal to 30 centimeters square, which is A2. Finally, the total area of the shaded region would be A1, twice of the A1 minus A2. And then finally your area A would be equal to, subtracting 64.3 minus 30, the answer will be 34.3 centimeter square. This is the area of the shaded region. Question number 5. The diagram shows a solid cone which has a slant height of 15 centimeter and a vertical height of h centimeter. Show that the volume V centimeter cube of the cone is given by this formula. The volume of the cone of radius r and vertical height h is given by. So this is the formula for a cone, volume formula for the cone. You can use this formula to drive your required equation, and h is given. So if you see that the general formula of the cone, which is V is equal to 1/3 of r square into h. This is general formula for a cone. And the required formula that we need to drive in our part 1 does not involve r. This is in terms of only h. So we will have to eliminate or get rid of this r from the formula. And how do we do that? If you see the diagram and if you draw this, so this is h and this one is the radius r. Now clearly you can find in terms r in terms of h using Pythagoras theorem. So r square would be equal to 15 square minus h squared. And then you can replace the value of r square in the formula. So V is equal to 1/3 of r square, and r square is 15 square minus h square, which is 1/3 of, sorry, I forgot here to write, sorry, pi. Pi is also given here because pi is always involved in volume formula. So 1/3 of pi, 15 square, which is 225 minus h squared into h, this one. So I just substitute value of r square here. And if you rearrange or you multiply this h inside the bracket only, so V is equal to 1/3 of pi into 225 h minus h squared, which is h cube. So this is your required expression or required equation that you need to drive here. Part 2. Given that h can vary, find the value of h for which V has a stationary value. Determine, showing all necessary working, the nature of this stationary value. So remember, whenever they talk about the word stationary value with regard some formula and nature of this stationary value, that means you need to find either maximum or minimum value. So it's all about calculus and differentiation. So the idea is, first we are going to find the first derivative. That means V depends on h, so we are going to find dV by dH, and then making it 0 we can figure out value of h. So this when you find dV by dH, making it equating to with 0, finding h, so this h will be the stationary point. And then using double derivative we can figure out whether the h is minima or maxima. It depends on the sign of the double derivative. So let's work out first the first derivative, dV by dH. Remember, V is equal to 1/3 pi 225h minus h cube. So if you differentiate, this is just for your information, if you differentiate this, so dV by dH is equal to 1/3 of pi. This is constant, so 1/3 of pi stays the same, inside the bracket, derivative of 225h is only 225 minus an h cube, derivative of h cube is 3h squared, bracket close. So for a stationary point, since dv by dh should be equal to 0, so you can say that should be equal to 1/3 of pi 225 minus 3h square, and it is equal to 0, so 1/3 of pi goes to the other side and becomes 0. That means 225h 225 minus 3h square is equal to 0, and then 3h square is equal to 225, and h square is equal to 225 divided by 3. Finally, so h is equal to 15 by root 3, because if you take the square root, so h is equal to root of 225 is 15 and then root 3. So you can write without root, so rationalize this. You can leave it here, but we don't write root in denominator, so you can write root 3, meaning rationalize it. So multiply by root 3 divided by root 3, so we are rationalizing. So final answer of h would be, so h is equal to 15 root 3 by 3. So 3 and 5, 15 gone, so h is equal to 5 root 3. It is in centimeter. So this is your value of h. That's what you need to find. Given that h can vary, find the value of h. This is the value of h for which we have a stationary value. Next, we need to find the nature of this value, whether at 5 root 3 we have a maximum or a minimum value of the volume. So we need to find now second derivative. So d2v by dh square. So you differentiate again your first derivative, and your first derivative was 1/3 of pi 225 minus 3h square. So if you differentiate this equation again, so 1/3 of pi stays the same. Inside the bracket, 225 is a constant, derivative of 225 is 0, and then derivative of minus 3h squared is minus 2 comes down, so minus 6h, and then this minus comes outside, so d2v by dh squared is equal to 3, and this 6 is gone, so 2, so minus 2 pi 3 2 minus 2 pi h. This is minus 2 pi h. Clearly, you say that whatever the value of h is, because h is positive, this is height, h is always positive. That means d2v by dh square is negative. That means this implies that the v is negative, maximum at h equal to 5 root 3. So this is the nature of the value of h. Question number 6. Given that x is positive, find the two smallest value of x in radians for which 3 tangent 2x plus 1 is equal to 1. Show all necessary working. Okay, so this is basically a question of a solution of a trigonometric equation. So we just solve this equation for x, small x. and just simplify this equation. So send 3 out to the other side. So tangent 2x plus 1, this is the angle, is equal to 1 upon 3. And then 2x plus 1 angle is equal to tangent inverse 1 upon 3. Again, this is intermediate step. If you wish, you can skip, you can directly write the values. So 2x plus 1 is equal to tangent inverse 1/3. If you find tangent inverse 1/3, the answer will be 0.32. 0.32 radian. So this is the angle of tangent at which you have a 0.32, and this is the tangent function. So you know that 0. Yeah, so tangent is 0.32. It will be right, 0.322. Let me just say yes, 0.322. So this is the tangent function, and tangent function is a periodic function. So period of the tangent function is 180 into n, or pi n. Pi n. N is number of rotation, 1, 2, 3, 4, 5, so on. So the first value of 2x plus 1, you can say 2x plus 1 is equal to pi, if you put n equal to 1, so pi plus 0.322. And now you can solve this for x. So 2x is equal to pi plus 0.322, so it will be 3.46, and then minus 1 here, and then x is equal to 1.23. This is your first value of x. Also, the second value will be if your angle 2x plus 1, the same angle, will give you second value. So 2 pi plus 0.322, and then again you do the same step, simplifying for x. So x is equal to 2.8. You can say radian, and then radian. If they ask you find the three values, so you can say 3 pi plus something like that and solve for x. That's how you find the two values. Part B, the function f 3x square x minus 2 sine square x is defined as for interval 0 to pi. Express fx in the form of a cos x cos square x plus b, where a, b are constants. So you are given a function, solution for 1, b1. So you are given a function f of x in terms of cos and sine. So 3 cos square x minus 2 sine square x. And you need to rewrite the function only in terms of cos. So you don't need sine. That means you need to get rid of the sine from this given function. So just substitute or replace this sine square with the value of cos, and you know that sine square is 1 minus cos square. So sine square x is equal to 1 minus cos square x. That's what we do here to just get rid of the sine. So 3 cos square x minus twice of 1 minus cos square of x, and simplify the right hand side. So you can have 3 cos square and then minus 2 times 1 is minus 2, and then plus 2 cos square x. 2 plus 3 is 5 cos square of x, and then minus 2. This is your function in terms of cos in the form of a cos square x plus b. So this implies that a is equal to 5, which is coefficient of x square, and b is equal to minus 2, the constant term in the function. Okay, find the range of the function f. So if you need to find the range of the function f, so you just substitute the minimum and the maximum value of the function of the domain or value of x. This is minimum and this is maximum. If you substitute this in the function, it will give you the minimum and maximum range. So now f of 0, if you put f of 0 here, so f of 0, 5 times of cos square, cos is square of 0 minus 2. Clearly cos 0 is 0 and square again 0, so 0 times 5 0, so that means minus 2. So f of 0 is minus 2. Also substitute pi, so f of pi is equal to 5 times of cos square of pi minus 2. So cos square of pi, so cos pi is minus 1, and minus 1 is square. If you wish, I'm just writing, you can do directly. So cos pi is minus 1, but you have a square on that, minus 2, which is square, make it positive, so 5 minus 2, that means 3. So the range is minus 2 to 3. This is the range. This is the range. Thank you very much for this video. I hope you understood. Have a nice time.